Hello guys, in this video we're going to perform an exercise regarding the contamination transport from the landfill area. Here is our exercise in which we need to know um, from the land side the contamination transport from the landfill area. Either it is towards the river side or towards the pumping well. Here is a problem formulation. A proposal has been submitted to local authorities for construction of landfill in the area shown figure that developers are creating landfill area in the vicinity of this site, which is the landfill area is of 1 by 1 kilometer, and the total extent of the area is 18,000 meter by 18,000 meter. Here is the river boundary, and here is the adjoining hillside area, and also the flow system is comprised of 110-meter thick unconfined sandy aquifer with following are the properties of the aquifer medium. The aquifer is of 110-meter thick and having the hydraulic conductivity of following figures: effect porosity and dispersivity of 10 meter. The regional groundwater flow direction is from east to west from the adjoining hillsides towards the river, and having the recharge of 1.2 exponent minus 8, and across the western boundary, eastern boundary, with the adjoining hillside, there is surplus recharge of exponent minus 9. So the landfill developers claim that the landfill is outside the capture zone of the proposed well, and that any effluent from the landfill will reach the river sufficiently diluted to meet regulatory standards. Local authorities would like to investigate this claim to determine whether the contaminant flow migrate towards the pumping well or the river. So for that we need to start our exercise. We need to open Modflow 8, processing Modflow, and create our new model, selecting my folder for the exercise is Modflow projects. It is now okay. Select the folder exercise and exercise and save it. Now the first step is to create a mesh size for our area, for which we need to study number of layers. Open our exercise. There is only one aquifer which is unconfined, and the thickness of the aquifer is 110 meter. So there is only one layer. The thickness of the aquifer is 110, and assuming that the model thickness is the datum, so we can also set the top elevation 110. The model extent, we can see the figure. The model extent, it is 18,000 meter by 18,000 meter. So we set the value 18,000 meter, and how many number of rows and column we need to set here. So grid cells of 500 meter by 500 meter is comprised between accuracy and computation time. So divide the extent of the area by the cell size. 18,000 divided by 500, 36. So number of rows 36, number of column 36, and OK, and save it. Now second procedure, layer property. Here are multiple property confined and confined, but our aquifer system is sandy aquifer and it's an unconfined. So we're going to select the second option, which is unconfined. Okay. Now cell status I-bound Modflow. You can see each cell represent here the one, which means all cells are active, and we remain it active. So save it, yes. Now parameters, initial and prescribed hydraulic heads. So our hydraulic head is 110 meter, and save it. Horizontal hydraulic conductivity of a reservoir medium. So the flow system hydraulic conductivity is 4.6 exponent minus 4, 4.6 exponent minus 4. Okay, and save it. Yes. Now effective porosity value of a reservoir medium is zero point 0.1. So change it to zero point 0.1 and save it. Now we need to add different packages regarding our study area. If we see our figure that here is a aerial recharge and a river and a pumping well. So here is three kind of flow packages and recharge, river and a well. So first we're going to select recharge. So we're going to select recharge now. The aerial recharge of the study area is open or exercise, and the regional groundwater flow direction is from east to west. Inflow occur as aerial recharge 1.2 exponent minus 8. Copy this value and paste it here. Now if we see the diagram, that eastern boundary had as another inflow which is 1 exponent minus 9. So we're going to add both of them for eastern boundary. So now select this cell at eastern boundary, and by adding these two figure it will become 1.3 exponent is to power minus 8 and make a boundary. So copy it and make a boundary in the eastern part of the sheet and save it. Now add another package which is a river. So river is at the western part of our sheet. By select this cell and right click the hydraulic conductance of the river bed. Here is the hydraulic conductance of the river bed, which is acquired by this formula, hydraulic conductivity times the length of the cell and the width of the river divided by 1, which is the thickness of the sediment at the bottom. So it become 5.85 meter square per second. 5.85. Head in the river is as it is the thickness, which is 110, and the elevation of the river bed we can subtract the depth of the river from the head, which is 110 minus 10, so it will become 100. Now by selecting this tab, make a river boundary in the western part of your area and save it. Now we need to set the well location. For that we need to add a well from flow packages. So here we can see the well is at the center part of our study area. So it is cell selected and injection rate of the well, but it is a discharging well. So the discharge from this well is 2.2 cubic meter per second. So 2.2 and represent it with negative sign cause it is outflow. It is a discharge, not an inflow. Okay. After that, we're going to run a model to see everything is okay. Yeah, it seems okay, good. Now for a 3D multi-dimensional simulation, we're going to select this option model empty 3D with simulation setting. Select this first cell, new add a new species and OK. Now initial concentration, we do not have any initial concentration, assuming it as a constant zero value of each cell and save it. After that advection, OK, and further add dispersion. The dispersivity is given here, which is 10 meter. So value reset matrix and change it to 10 and save it. After that, sink source concentration of our landfill area. So added it here is of our landfill area having recharge concentration of 1000 cubic meter per milligram per cubic meter. So select this cell and change it to 1000. Each cell represents 500 meter, but our landfill area is 1 by 1 kilometer. For that, we need to add more 3 cells, copy it, and select whole our landfill area and save it. Yes. After that, Modflow, yes. After that, we need to set time for the simulation, output time and output interval. Simulation time period, we need to see the to 200 years. So copy it from here and paste it here. Okay. For interval, go to MP3DBS, CVET, output control, output time, the interval is 3.15 exponent is to power 8 and paste it here. The simulation is divided into 22 steps. Now run the MT3DMS module. Okay. It seems good. Go to tool, 2D visualization, MD3DMS. Okay. Simulation time, change it to max 200 option environment and tool level, change interval to 5 minimum. Okay, label format fixed. Here it is, and you can see the contamination transport are towards the pumping well instead of a river boundary. So the all the contamination from the landfill area will contaminate the pumping well zone instead of a river. So here is the outcome of our exercise for the animation of 200 years. change it to 5. Select folder exercise, make a new folder, name it animation, and file name to animate. Here it is. Animation, sorry. Here it is. You can see the contamination from the landfill area are contaminating the pumping well area instead of a river. So it is the outcome of our exercise. The authorities want to know to determine whether the contaminant plume migrates towards the pumping well or towards the riverside. So you can see the simulation of a contaminant transport. Thank you. See you in our next video. Take care.